I would like to make a disclaimer that the following video is my final presentation for a class at UAMS and represents a hypothetical scenario. The following presentation does not necessarily reflect the views of UAMS or any other agent. Good morning. I would like to start by thanking everyone for being here today, especially my supervisors and boss, Mr. Smith. My name is Caitlin Hirsch, and I'm an environmental health specialist with the Arkansas Department for Environmental Quality. Approximately 120 miles southeast of Little Rock is the town of Crossett, Arkansas. Within its borders is a plywood paper mill and formaldehyde resin facility. However, what once was a prosperous addition to the town is now suspected to be the source of a cancer cluster in the surrounding area. Community members believe the facility is dumping waste into the air and waterways. In response to community concerns, I propose launching a proper investigation of the facility and correlated adverse health events. Throughout my presentation, I will address community concerns and provide supporting information for the proposed conduction of an investigation. Among this include discussions regarding emissions, specific health hazard information, and a proposed four-step process for evaluating a suspected cancer cluster. I will begin by looking at emissions, starting with the toxic release inventory for the facility in question, Georgia Pacific Crossett Paper Operations. According to the EPA, U.S. facilities must report annually the amount of chemicals released into the environment. The information is then compiled and used as a method to manage certain toxic chemicals that may pose a threat to human health and/or the environment. The goal is to provide accurate, objective information regarding the emission history at the facility. I also will propose the conduction of whole air and water sampling and analysis, and I will explain the importance of such information to an investigation. First, I want to direct your attention to the topmost graph, which demonstrates a 15-year trend in the waste management of 42 production-related chemical wastes, 10 of which the company reports as carcinogenic. For both graphs, the legend is as follows. Green represents recycled, blue represents energy recovery, yellow represents treated, and red represents released. The graph at the bottom demonstrates waste management activity in pounds for the same production-related chemical waste as the graph above. The next two graphs are specific for the 10 carcinogenic wastes formed from the production process. Once again, the legends are the same as previously stated. I would like you to first direct your attention to the topmost graph, which demonstrates a 15-year trend in the waste management of these 10 specific production-related chemical wastes. The graph at the bottom demonstrates waste management activity in pounds for those carcinogenic wastes. Note, of the approximately 5.8 million pounds of carcinogenic waste created by production, over 25% was released. This slide will further examine Georgia Pacific's releases of carcinogenic compounds over a 15-year time period. The topmost graph demonstrates the trend in releases of the 10 carcinogenic chemicals. Each bar is composed of colors that represent the pounds of one specific chemical to the total pounds of all 10 carcinogenic chemicals released per year. Blue represents acetaldehyde and green represents formaldehyde, while yellow represents lead compounds. As you can see, the former easily compose the majority of releases each year for the entirety of the reported years. The graph on the bottom looks at the releases of only acetaldehyde and formaldehyde to the environment during that time period. Note that the legend has changed. Green now represents water, blue represents air, yellow represents off-site, and red represents land. It is important to note the predominance of air and water release, especially in respect to acetaldehyde and formaldehyde waste. Thus, I think it is important to conduct whole air and water sampling and analysis. Whole air sampling consists of collecting a sample of ambient air for analysis. Air is collected into a sealable container such as a canister or sampling bag. Collection can be over a short period of time as grab samples or integrated over a longer period of time to obtain time-weighted average concentrations. Samples are then sent for subsequent analysis to characterize particles and assess for potential volatile chemicals. Specific to this inquiry, we will determine how much, if any, air contains acetaldehyde, formaldehyde, or any of the other carcinogenic compounds produced by the plant in question. Water sampling consists of collecting a representative sample of water from the source of inquiry for subsequent analysis. Grab sampling is the most common form of sampling because it is reliable and easy to do. The sample is then placed into a cooler box with ice and taken for analysis. Subsequent chemistry analysis is performed to identify and quantify the chemical components and properties of the sample. Chemical water analysis is additionally used to test for potential volatile chemicals in lakes, rivers, and groundwater. Once again, we will look specifically for acetaldehyde, formaldehyde, and other carcinogenic wastes. Now, I will analyze the suspected emissions, specifically formaldehyde and acetaldehyde, and provide specific health hazard information of these substances. Let's begin with formaldehyde. The acute effects of formaldehyde exposure depend heavily on the route of exposure. For inhalation, primary effects include eye, nose, and throat irritation, as well as coughing, wheezing, chest pains, and bronchitis. For ingestion, corrosion of the gastrointestinal tract is common, as is inflammation and ulceration of the mouth, esophagus, and stomach. Chronic effects of formaldehyde include respiratory symptoms in eye, nose, and throat irritation. There has also been reported effects on the nasal respiratory epithelium and subsequent lesion formation within the respiratory tract. Sensitization as a result of formaldehyde exposure is also a concern. Sensitized individuals are at an increased risk for development of asthma and contact dermatitis. Formaldehyde is classified by the International Agency for Research on Cancer as carcinogenic to humans. The IARC warns that formaldehyde causes nasopharyngeal cancer in humans. This was in response to a cohort study conducted by the U.S. National Cancer Institute that was further supported by positive findings in other studies. Recently, the IARC also stated that there is sufficient evidence to support the claim that formaldehyde may also cause myeloid leukemia in humans. Now we will examine the effects of acetaldehyde. For this chemical, the acute effects of exposure include eye, nose, and respiratory throat irritation, as well as erythema, coughing, pulmonary edema, and potential necrosis. Acute inhalation of the toxin also may cause depressed respiratory rate and elevated blood pressure. The effects of chronic exposure can cause changes in the nasal mucosa and trachea, growth retardation, slight anemia, and increased kidney weight. The National Toxicology Program of the U.S. Department of Health and Human Services lists acetaldehyde as a known human carcinogen. Exposure increases the risk of head and neck cancers, esophageal cancer, liver cancer, colorectal cancer, and even breast cancer. Now, I will outline a four-step process for evaluating potential cancer clusters using revised CDC guidelines. These are recommended in response to a report of a suspected cancer cluster and include procedures, guidance, and considerations for closing the inquiry or proceeding to the next step. The first step is initial contact and response. First, information will be collected from the inquirer so as to determine whether the concern warrants further follow-up. The inquirer in this case is the community representative that called and emailed the report of a suspected cancer cluster. On the basis of the information collected, we will then determine whether it is appropriate to move forward with an investigation. The gathered information should include the types of cancer and number of cases of each type, the age of people with cancer, the geographic area of concern, and the period over which cancers were diagnosed. It is also important to include information about specific environmental hazards or concerns and other risk factors, including diet, infections, and family history. The suspected source is Georgia-Pacific, but other potential sources will also need to be evaluated. Based on the information provided, we will then make the decision whether or not to further pursue the inquiry. For instance, the information provided must fit the definition of a cluster, and there must be biological plausibility to support a potential common etiology of the cancers in question. If the data presented suggests the need for further evaluation, then we will proceed to step 2, assessment. The purpose of the assessment step is to determine whether the suspected cancer cluster is a statistically significant excess. Several components are required for the assessment step, including collection, analysis, and interpretation of relevant data. To ensure cases are selected based on objective inclusion and exclusion criteria, there must be a well-defined case definition. It will need to include demographic characteristics, geographic area, and time period of concern, and information on the type of cancer, such as primary site, histology, and grade. The population of concern, or the study population, will also need to be exclusively defined. For instance, we will identify and select a specific geographic area, such as a defined area of exposure within CrossFit, and a specific time period for which that exposure took place. For decisions regarding the choice of comparison cancer rates and statistical methods, I recommend a collaboration with an epidemiologist. This step further involves identification of local environmental concerns, which should include creation of a communication plan with key community members. There should also be a calculation of a standardized incidence ratio, which is a means by which we can estimate the likelihood that there is an excess of cases existing in the population of concern compared to the general population. It is a ratio of the number of observed cases, i.e., the cases that occurred in the population of concern, to the number of expected cases, i.e., the cases that would occur in the study population if the occurrence of cancer in that population was the same as the reference population. It will also be useful to calculate incidence rates and ensure a 95% confidence interval is included for all statistics when possible. If review of the statistical analysis yields significance, the investigation will move forward to step 3. This step focuses on assessing the feasibility of conducting an epidemiological study to examine the association between the cancer cluster and a particular environmental contaminant. There will be collaboration with community, environmental, and local public health partners throughout this step. For instance, it is important to evaluate community needs and wants and to assess the feasibility of addressing those concerns. First, we will identify hypotheses. Past public health agency reports will also be reviewed to assess for other inquiries and investigations related to the same types of cancer. Next, we will identify the study population based on the definition determined in the previous step, and then determine what descriptive, health, and risk factor data should be collected. Then, we will further research available data on the environmental contaminants of concern, in this case, the chemical releases of Georgia-Pacific. Once again, we will need to ascertain the plausibility that the cases and contaminants could be associated. Furthermore, it will also be imperative to identify study design requirements and available resources to conduct the study. If the above steps suggest an investigation is further warranted, then we will proceed to the fourth and final step. The final step is conducting an epidemiological investigation. The purpose of this step is to determine if the exposure to the specific environmental contaminant might be associated with the suspected cancer cluster. It will require the development of a protocol and implementation of a study that tests the hypothesis of an association between specific cancer types and environmental exposures. It is important to note that an investigation might not demonstrate a conclusive association between the suspected environmental contamination and cancer cluster. However, it is possible the exposure might still be linked to the cluster, which may require more scientific information for further assessment. On the other hand, other risk factors such as smoking, personal behavior, and occupational exposures should also be further investigated. This concludes my presentation. Here is a list of the resources I used in the creation of this presentation. I would like to once again thank you for your time and consideration. Have a great day.